Hello friends, welcome to this video and continuing our discussion from our previous video to find the majority element in a given array. Today we will be seeing Moore's voting algorithm to find the majority element in a given array. So we have seen that the majority element is the element which occurs more than n by 2 times, where n is the length of the array. So that is the majority element, and using Moore's voting algorithm we'll do this in two steps for finding this majority element which is occurring more than n by 2 times, where n is the length of the array. So the first step is finding the candidate element. So the candidate element is the element which can likely be the majority element, but it is not a majority element. So that is what we are going to do in the first step, find the candidate element. So there is a procedure for doing that. And the second step is confirming whether that candidate element is the majority element. So there are two steps in this. One is the finding the candidate element, and the second step is confirming if the candidate element is the majority element. If we confirm it as a majority element, we will return it as a majority element, or else we'll just say majority element doesn't exist. So only two steps are there. This is a very simple algorithm. The only thing which can get tricky is understanding the logic find the candidate element. Okay, so finding the candidate element can be a little tricky. So if you get this part, then you have understood the Moore's voting algorithm. So now let's see how to find the candidate element. So as I've said previously, candidate element is the element which is likely to be the majority element, right? So what is we have already seen that the majority element is nothing but an element in the given array which has more than n by 2 times occurrence, right? Its occurrence is more than n by 2, where n is the length of the array. So if it means that here, if I have my array which is of length n, okay, this is of length n. So this is my array. Let's say this is my array, and this is the half. This is the middle of the array, which it's denoted by the n by 2 position, and next to it is the n by 2 plus 1th position. Okay. Till here we have n by 2 plus. If we have an element x, let's say we have an element x in the array, and if this element x occurs n by 2 plus 1 times in this entire array of length n, then it is very clear that x itself is the majority element, right? Because majority element can be only 1, and it is occurring n by 2 plus 1 time, that is greater than n by 2. So x is the majority element. So it will occur in this area, right? In this complete area from the starting index to the last index n by 2 plus 1, x is going to occur those many times, n by 2 plus 1 times. So x is the majority element. Now the rest of the elements n by 2 minus 1 can be any element. It can be x as well, or it can be any other element which is different from x. Okay, so even though their existence will not affect the fact that x is a majority element, because x has already occurred n by 2 plus 1 times, right? So it has met our criterion for being or qualifying as the majority element. So no matter what are all the elements present in this part, it can be x or it can be any other element, it doesn't affect the fact that x is the majority element. X will still be the majority element no matter what is there in the rest of the array, which occupies the n by 2 minus 1 positions. Okay, because already n by 2 plus 1 is occupied by x, so remaining n by 2 minus 1 positions are occupied by the other elements. Now these other elements we know that these other elements cannot change the fact that x is the majority element, because x has already occurred n by 2 plus 1 times. Now using this information, we will write our procedure to identify the candidate element, right? So what we do is, the concept is very simple. You assume the very first element to be the candidate element x, okay? Then you track the count of that particular element. Okay, so very first encounter, its count will be 1. You keep traversing the array forward, and till n, when you reach this n by 2 plus 1 position, the count will obviously become n by 2 plus 1, right? Now when the count becomes n by 2 position, on the next immediate movement, when you go to the next element, so if you go here, since all of these, let's take all of these are unique elements which are not equal to x, right? So in that case, we will decrement the count. Okay, so by the time you reach the end of the array, so immediately the next moment it will become n by 2. Then later if we traverse, it will become n by 2 minus 1. Okay, then later if we keep on traversing till the end of the array, it will become n by 2 plus 1 is the number of times x occurred, plus the rest of the elements are n by 2 minus 1, right? So we have to subtract n by 2 minus 1 from it. So I need to subtract this n by 2 plus 1 occurrences of this x from the rest of the elements which are different from x, that is n by 2 minus 1 elements. So even then I get these two gets cancelled, and I get a positive 2 which is greater than 0, right? So still, so it proves that if you have x as the majority element, no matter how many elements are there in the array apart from x, they can never make this count value less than 0. Okay, they can never make this count value less than 0 if x is the majority element. So that, using that fact, we are going to compute our algorithm. So to find the candidate element, what we do is very simple. So here you can see the code. Here it's very simple. To find the candidate element, we will first assume our candidate element to be at the first index itself. We'll assume its count to be 1. Then we'll traverse the entire array. We will see each element of the array whether it's equal to the candidate element. If it is equal to the candidate element which we have selected, we will increment its count, else we'll decrement its count. Okay, at any point of time, if its count becomes 0, it means it cannot qualify as a candidate element, because if you see, if this x, it does not, it's, if it is count will be 0 only when this red part is more than this green part, right? So here is our green part which indicates the occurrences of x, and here is the red part which indicates the occurrences of the other elements. So if the count is becoming 0, means this red part obviously is more than this green part. So in that case, you see, this x can never meet the condition of this majority element n by 2, because it will terminate somewhere over here itself, right, which is less than n by 2. Okay, so the x can never qualify as the candidate element. So that's why if it count becomes to 0, I will set the element current, whatever the index I am at. So that is nothing but let's say here the count of x becomes 0. So the next immediate element over here, I will set it as the candidate element. Okay, I will assume it as the candidate element, and then I will set it count as 1 since I'm encountering it the first time, and then I'll repeat this process. So finally I will get an element which is likely to be the majority element, because it's not guaranteed that it is a majority element. For example, consider the following case. So for example, consider the following case wherein I have 4 elements, 2, 4, 2, 4. Now very first time the count of this 2 will be 1. Okay, then immediately when I encounter 4, it count will become, I will decrement it count, it will become 0. So see this. So I'll start from the very first index, that is 2. So its count is 1. Okay, so here candidate element is 0, that is 2, and its count is 1. Then I'll traverse the array from the next position, from 1 till the end of the array. Then I'll see if this the next element is equal to 2. No, it's not equal to 2, so I'll decrement the count. So the count of 2 will become 0. So as soon as it becomes 0, I will make the next element as my candidate element, and I will set it count as 1, right? So here I will make the count of 4 as 1. Then I will traverse further. Okay, then I'll get 2. So again 2 is not equal to 4, so I will decrement the count of 4 to, then it will become 0. So if it is becoming 0, then I will set the next element to be my candidate element, and I'll set it count at 1. So again 2's count will be becoming 1, and again at the last element I'm getting 4, so it's not equal to 2, so it will decrement the count of 2, it will become to 0. I'll set the candidate element index as 4, and I will set its count as 1. So here you can see at the end I am returning the candidate element index as this 4 value, right? So this is the third index, so I will return 3 index as the majority. So I will return the 3 index as the candidate element index. But is 4 really the candidate element? Because there are 4 elements in the array, and if you divide it by 2, you will get 2. So the in order for the candidate element to be qualified as the majority element, its frequency should be greater than 2. So in order for this candidate element 4 to be qualified as the majority element, its frequency of occurrence must be greater than 2, because the length of the array is 4 and half of that is 2, so it should be greater than 2. That is, it should be at least 3. But is 4 getting repeated 3 times? No, it's only getting repeated 2 times, right? But still we are returning the index 3, which is pointing to 4, right? So 4 is a likely element to be the majority element because its occurrences is 2, which is very near to 3, right? So that is what candidate element is. It's the likely to be majority element, but it's not the majority element. Then later we have to confirm whatever we have selected as the candidate element is the majority element. So that is we will do by another function which is nothing but is majority element. So we'll pass our candidate element and the array. So this is what our n by 2 expected count is, right? This is what our n by 2. So this is what our expected count is, and we'll traverse over the entire array and we will check the frequency of occurrence of whatever we have chosen as the candidate element, right? And we'll count the number of occurrences of it, and then we'll see if it is greater than the expected count, which is nothing but greater than half of the length of the array. Only in that case we'll return true, and only in that case the majority element will exist. Okay, and in the rest of the case we'll return false. It means that the majority element does not exist. So here is my find majority element method, wherein first I will find the candidate element, okay, and then I will pass this candidate element to my isMajority function, which will confirm whether my candidate element is the majority element, and if so I will return that candidate element, or I will print majority element does not exist. So here is my main method. So I have taken the same example from our previous video, and here I am invoking the find majority element for the array A. So let's run this. So yeah, it's printing majority element is 3 because I have 5 elements and 3 is occurring 3 times. And if I increase the length of the array to 6, then it says the majority element doesn't exist because 3 should occur at least 4 times now. So if I make it occur 4 times, it will say majority element is 3. Yeah, so that is about the Moore's voting algorithm. Yeah, so that is how the Moore's voting algorithm. Its time complexity is big O of n, that is where n is the length of the array. Big O of n because we here in there are only two functions. One is find the candidate element. Okay, so this takes order of n time because we are traversing the array only once. Okay, and then we have is majority element. So this also takes a constant order. So this also takes order of n time because here also we are traversing the array only once. So big O of n plus big O of n is big O of n. So here we are getting the time complexity of this entire function to be big O of n, where n is the length of the array. And the auxiliary space complexity, we are not using any extra space, so it is big O of 1. Yeah, so that's about the Moore's voting algorithm. So only 2 steps you have to remember. One is finding the candidate element. Second is confirming whether the candidate element is the majority element. So that's all about the Moore's voting algorithm. Thanks for watching this video.